Picture Saturn the way you've always known it. Pale gold clouds, a thin white ring, a calm, distant world that hasn't changed since you first saw it in a textbook. Now delete that image. In late 2024, a telescope parked 1 million miles from Earth pointed its mirrors at Saturn and returned something almost unrecognizable. The planet's clouds glowed in bands of burnt orange and pale tan. Its poles turned an eerie gray-green, as if lit from beneath. And its rings, the famous rings, didn't just shine. They blazed, brighter and sharper than almost anyone had seen them before. This wasn't science fiction. It was the James Webb Space Telescope, working in partnership with the older Hubble Space Telescope, producing what NASA and the European Space Agency would call the most comprehensive view of Saturn ever assembled. 2 instruments, 2 kinds of light, 1 planet, revealed in a way that even decades of prior exploration hadn't managed. And buried inside that new imagery were details nobody had fully explained yet. Jet streams behaving strangely, storm remnants still lingering from over a decade ago, and mysterious structures near the North Pole that scientists flatly admitted they could not account for. This is the story of how Webb saw Saturn differently than anyone else, why that difference matters, and what it revealed that even Saturn's most dedicated visitor, a spacecraft called Cassini, never got to see. Let's start with the foundation, because this isn't speculation. It's documented observation, credited to real people, real institutions, and a real timeline. The James Webb Space Telescope is a joint mission of NASA, the European Space Agency, and the Canadian Space Agency. It first turned its instruments towards Saturn on June 25, 2023, using its near-infrared camera, known as NIRCam, as part of a guaranteed time observation program. That early look was already strange enough to make headlines. Saturn's clouds appeared almost pitch black, while its icy rings blazed with light. Then, on November 29, 2024, Webb returned to Saturn again, this time using director's discretionary time, essentially an allocation of prime telescope hours reserved for especially valuable observations. Just a few months earlier, in August 2024, Hubble had captured its own view of Saturn as part of a long-running program called OPAL, the Outer Planet Atmosphere's Legacy Survey, led by NASA researcher Amy Simon. The 2 images, 1 infrared and 1 visible light, were processed and released together with image processing credited to Joseph de Pasquale A. at the Space Telescope Science Institute, and additional analysis credited to Michael Wong at the University of California, Berkeley. In short, this wasn't a rumor, a leak, or a single scientist's pet theory. It was a coordinated, published observation campaign, backed by 2 space telescopes and multiple named research teams. Go back to that first 2023 observation for a moment, because it set the stage for everything that followed. When Webb's NIRCam locked onto Saturn that June, the image that came back looked almost inverted from what anyone expected. The planet's disk appeared nearly black, its rings appeared blinding white. At the time, that alone was enough to fascinate the researchers running the program, because it hinted at just how differently this telescope was going to render a world that had already been photographed thousands of times by ground-based observatories and by Cassini itself. That single test image became the seed for a much larger campaign, one that would eventually pair Webb's infrared vision with Hubble's decades of visible light monitoring. So why did NASA and ESA think this was worth the effort? Because Saturn, despite being one of the most photographed objects in the solar system, has never been an easy planet to fully understand. Here's the part that makes this story work. Webb didn't just take a prettier picture of Saturn, it took a different kind of picture, and that difference is the whole point. Think about shining a flashlight through your hand. In ordinary light, all you see is skin. But if you had a special kind of light that could pass through flesh and only get stopped by bone, you'd suddenly see structure you never knew was there. That's roughly what infrared light does to Saturn's atmosphere. Hubble observes Saturn mostly in visible light, the same kind of light your eyes use. The light reflects off the very top of Saturn's clouds, which is why Hubble's images show soft yellow bands and subtle color shifts, almost like looking at the surface of a painting. Webb, on the other hand, observes primarily in infrared. And infrared light doesn't stop at the surface. It penetrates deeper, interacting differently with different gases and hazes at different altitudes. Some wavelengths get absorbed by methane gas high in the atmosphere. Others slip past that layer and reflect off clouds sitting much farther down. The result is that Webb doesn't just see Saturn's face, it sees through it, layer by layer. A bit like peeling back the layers of an onion, as NASA itself described it. Each depth tells a different part of the story. Temperature here, chemistry there, wind patterns somewhere else entirely. Put the 2 telescopes together and scientists aren't just looking at Saturn anymore. They're slicing it open. That distinction is easy to state and easy to underestimate. For most of the history of planetary astronomy, a picture of Saturn was just that, a picture. a flat, two-dimensional impression of light bouncing off the outermost layer of cloud. Depth had to be inferred indirectly, through models, through years of accumulated data, through careful mathematics rather than direct observation. What Webb's infrared sensitivity offers is something closer to a direct look at that depth. Not a perfect one, no single observation ever is, but a meaningfully closer one than anything achieved from a similar vantage point before. Once you understand that principle, the individual details in Webb's imagery stop being random curiosities. They become clues in a bigger investigation. Start with the rings. In Webb's infrared view, Saturn's rings don't just glow, they practically ignite, appearing far brighter than the planet's clouds. That's because the rings are made largely of water ice. And water ice is extremely good at reflecting sunlight at the infrared wavelengths Webb was tuned to detect. Saturn's clouds, by contrast, contain methane gas that absorbs much of that same light. So in Webb's image, the planet's face goes dark while the rings blaze, a visual almost opposite to what you'd expect if you only knew Saturn from ordinary telescope photos. Then look higher, into the northern mid-latitudes, and you'll find something researchers named the ribbon wave, a long-lived jet stream that meanders across the planet like a slow, wandering river of atmosphere. It's driven partly by wave patterns in the deeper cloud layers, patterns that are essentially invisible unless you're looking in the right part of the infrared spectrum. Webb was looking in exactly the right part. Just below that ribbon, scientists spotted something else, a small, isolated spot, quietly persisting in Saturn's atmosphere. T isn't a new storm, it's a leftover, a lingering remnant of the great springtime storm, a massive disturbance that tore through Saturn's atmosphere between 2011 and 2012. More than a decade later, its ghost is apparently still drifting through the clouds, visible only because Webb's infrared eye could pick out the faint signature it left behind. And then there's the North Pole, the most visually strange part of the entire image. In Webb's data, both poles glow a distinct gray-green color corresponding to light emitted around 4.3 microns in wavelength. Researchers have proposed two possible explanations. One is a layer of high-altitude aerosols, tiny particles suspended in Saturn's upper atmosphere that scatter light differently at the poles than anywhere else on the planet. The other is auroral activity, charged particles interacting with Saturn's magnetic field, producing a glow similar in principle to Earth's northern lights, just on a planet nearly 10 times farther from the Sun. Neither explanation has been confirmed over the other. Both remain live possibilities. It's worth noticing how differently the two space telescopes rendered the same region. In Hubble's visible light image, Saturn's horizontal bands come across as pale yellow with a faint blue tint near the poles. Subtle, almost soft. In Webb's infrared image, taken only a few months later, those same latitudes turn a much darker orange near the poles, gradually lightening to tan closer to the equator, before giving way to that unmistakable gray-green glow right at the top. Same planet, same rough orientation, two completely different visual languages, because two completely different kinds of light were being measured. Let's pause here, because this is the point in the story where a smaller documentary would just move on to the next pretty picture. But there's a detail worth sitting with, because it changes how you should think about everything else in this story. Faintly visible in both the Webb and Hubble images is a structure planetary scientists have been fascinated by for more than 4 decades, Saturn's hexagon. It's a 6-sided jet stream sitting almost perfectly over the planet's north pole, first discovered by NASA's Voyager spacecraft back in 1981, and later studied in extraordinary detail by the Cassini orbiter between 2004 and 2017. Each side of the hexagon stretches roughly 14,500 kilometers, wider than the diameter of planet Earth itself. Decades of observation still haven't fully explained why Saturn's atmosphere organizes itself into a 6-sided shape instead of a circle, a spiral, or anything else. What scientists do know is that it appears remarkably stable, reappearing image after image, decade after decade, largely unchanged in outline even as the storms and bands around it shift. And here's the part that gives this Webb and Hubble campaign real urgency, not just aesthetic value. Because of Saturn's tilt and its 29.5-year orbit around the Sun, the planet's north pole is now heading toward winter. Within the next several years, that pole will rotate into darkness for roughly 15 years, which means these images, captured in November 2024, are very likely the last high-resolution, well-lit views of the hexagon that scientists will get until sometime in the 2040s. In other words, this wasn't just a nice photo opportunity. It may have been one of the final windows to study this exact feature under this exact lighting for a generation. Now here's where the story gets genuinely strange, because Webb hasn't only confirmed what scientists expected to find near that hexagon, it's also found something nobody predicted at all. Using a different instrument, the near-infrared spectrograph, or NIR spec, A separate Webb observation focused specifically on the atmosphere directly above the hexagonal storm. Over roughly 10 hours, the telescope tracked charged hydrogen molecules moving through Saturn's ionosphere, about 1,100 kilometers above the planet's cloud tops, along with methane distributed throughout that same region. What the team expected was fairly ordinary, broad, smooth emissions spread across the infrared spectrum. What they found instead were small, dark, bead-like structures drifting through the ionosphere, separated by enormous distances, yet appearing possibly connected. Beneath them, roughly 600 kilometers lower, in a layer called the stratosphere, the telescope picked out a lopsided, four-armed pattern shaped almost like an uneven star. Two of its arms looked stronger than the other two, giving the whole structure an asymmetric, off-balance appearance. Strangest of all, the darkest beads in the upper layer seemed to line up with the strongest arm of the star pattern beneath it. As lead researcher Tom Stallard put it, these features were completely unexpected, and, at least for now, completely unexplained. This is important because it tells you something about where this story actually stands. Saturn is not a solved planet. Cassini spent 13 years orbiting it, sending back some of the most detailed data ever collected about a gas giant. And even that wasn't enough to predict structures like this. Webb, using a completely different kind of vision, is now uncovering entirely new questions that Cassini's cameras simply couldn't see. So what does all of this actually establish? And what's still open? What's established? Webb and Hubble have jointly produced the most detailed multi-wavelength portrait of Saturn assembled to date, backed by named research teams, dated observations, and cross-checked instruments. The ribbon wave jet stream is real and documented. The remnant of the 2011-2012 Great Springtime Storm is a confirmed, tracked feature. The extreme brightness of the rings in infrared, caused by water-ice reflectivity, is well understood physics. What's still uncertain, the exact cause of the gray-green polar glow, aerosols or aurora, or possibly both. And the strange bead and star pattern above the hexagon remains, in the researchers' own words, unexplained. Follow-up. Webb observations are expected, in part because Saturn is currently near its equinox, a period when its atmospheric patterns are known to shift rapidly as sunlight strikes the planet at a changing angle. That distinction matters. This isn't a story about a mystery being wrapped up with a neat answer. It's a story about a very old planet still actively surprising the scientists who've spent their careers studying it. Which brings us back to where we started, with an image of Saturn that doesn't look like the one in your memory. Every visible moon in that November 2024 frame, Titan, Janus, Dione, Enceladus, Mimas, Tethys, Epimetheus, is a small reminder of just how much company Saturn keeps, and how much of that system is still being actively mapped, generation after generation of instruments later. If Webb's mission runs as long as engineers hope, potentially 10 years or more beyond its launch, it could end up observing Saturn across almost an entire Saturnian year, watching the planet drift from one season into the next, picking up exactly where Cassini's decade of observation left off. Scientists have described that possibility as something close to completing a full circle, closing the loop on nearly 50 years of continuous human observation of this one ringed world. For now, what we have is a single, extraordinarily detailed snapshot. Infrared and visible light, side by side, revealing a planet built in layers, most of which are still only partly understood. So here's the question worth sitting with. If a planet this photographed, this famous, this thoroughly visited by spacecraft, can still produce structures nobody predicted and effects nobody has fully explained, what does that tell you about everything else out there that we've looked at only once? If you had to guess what's causing those unexplained bead-like structures above Saturn's hexagon, aerosols, aurora, or something else entirely, drop your best explanation in the comments. And if this kind of deep, evidence-based space story is the kind of thing you want more of, you know what to do next.